So when I talk about a rational function, that's when you are dividing two polynomials. So something in form t of x over q of x, two polynomials being divided. The denominator cannot be 0, so it's not the 0 polynomial. So, when we graph these, it's going to be a little more involved than with just a plain polynomial. We have some of the same aspects when we were graphing polynomials. We had to find x and y intercepts, and we'll still use those, but there's a lot more that happens on these graphs. When we get into this, there are a lot of rules that we're going to use. And so to help you guys out, I actually have a page that I've typed up with all the different rules and things that we need. So that way you're not trying to copy all of this down. Okay, so I'm going to go ahead and give you this. I guess I could have given it to you 2 seconds ago because I did put the definition of rational function on here as well. But now you've wrote it down, so you will really remember it. So this is everything that we're going to be talking about today and Monday. When we're talking about rational functions, dividing things, we know that in a fraction, the denominator can't be 0. So if I'm looking at the domain of a rational function, it's just everything except what makes the denominator 0. And those numbers that make the denominator 0 are going to be the places where our graph does different things. So those are going to be the values that we really have to watch out for when we're graphing. So the first thing I want to do is just practice finding domains. Alright, so for the first one, if I wanted the domain of this function, I do not care about the numerator at all. I don't care if things cancel out. The domain is based off the original. We know in a fraction, the bottom of this fraction cannot be 0, so that means x cannot be -5. So domain is telling me everything that x can be. So if it can't be -5, what can it be? Everything sucks. So everything smaller than -5 and everything bigger than -5. Next one. So 1 over x squared minus 4. So all I care about is the denominator. So x squared minus 4 can't be 0. So that means x squared can't be 4. So what can x not be? Plus or minus 2. In general, I want the interval notation for the domain. But in the case where we have multiple values that x can't equal, I will allow you to just list them. So on the first one, it was only one number x can't be, so I want that full interval. On B, because it's more than one, I will accept this. Or if you want to really impress me, you can go ahead and give me the interval. It'll be everything smaller than -2, everything between -2 and 2, and everything bigger than 2. but that interval notation does get a little cumbersome when you have multiple things that x can't be. So if it's more than one, you list. All right, C. We know our denominator, x squared plus 1, cannot equal 0. Okay, so that means x squared can't be negative 1. What do we get there? I. When we graph, are we worried about i's? So what does that make my domain? When I look at D, my denominator is just 3. Does 3 ever equal 0? No. So if the denominator is never 0, what does that mean? E. X minus 1 can't be 0, so that means x can't be 1. So just one value, you can give me that interval, what would it be? Questions? So far, so good? You guys can find the domain of a rational function? All you look at is the denominator. Okay. One thing to note, and this is something that we do in algebra all the time. We reduce expressions and we rewrite them. But technically, these two things are not the same. Now, if you see x squared minus 1, you would factor that into x plus 1, x minus 1, divided by x minus 1, right? And those cancel. That's where I get the x plus 1. But I'm telling you, in terms of the graph, they're actually different. Because what's the domain of this one? Your x can't be 1. What's the domain of this one? So I put this on here just to illustrate a point. When I ask for the domain, it has to be off the original one. The difference in these, what would happen is when you graph them, so this is just a line, y-intercept of 1, slope of 1. X plus 1 would be a solid line. The original one, we will learn how to graph it in the coming days, will be a line with an open circle on it, because it would take out that single point when x is equal to 1. So, in terms of like plugging numbers in, it doesn't seem to matter, but the graph will. So when we're talking about how to graph things, it's always based off the original problem. So we have to take into consideration those original domains. Now we're going to start getting into some of our rules. So this is all printed on that handout I gave you, so you're not trying to just copy down a bunch of stuff. Asymptotes are lines that our graphs are getting close to without ever touching. So it's approaching that, getting closer and closer and closer. There are 3 types: horizontal, vertical, and oblique. Sometimes this is called a slant asymptote. We know what a horizontal line is, flat, straight across, right? Vertical line is up and down. Oblique is any slanted line. So any other line would qualify as an oblique. When we are drawing our graphs, there are times where it may cross a horizontal or an oblique asymptote, but a graph will never touch at its vertical asymptote. So something to keep in mind there. Now, as far as how we find these, there are some rules. First, I want to look at a graph and make sure we can pick out our asymptotes and things from that graph, and then we'll work up to the point where we can draw the graphs ourselves. gave you this one, could you tell me the domain of this function? Can you guys tell that our graph breaks when x equals 2? When we draw these, we would draw in an asymptote, and we'll just draw it as a dashed line. But that is a line that our graph is getting close to, but not actually crossing. What is the range? If we drew that in at 1, we can see, if we drew the horizontal line at 1, we're getting close to it, but we are not actually crossing that line. Intercepts. Can you tell me the x-intercept? Where does this graph cross the x-axis? 1. And if you wanted to, you could give me a 0.10. Either is fine with me. Y-intercept. Where does it cross the y-axis? 1/2. Or if I asked for the point, it would be 0, 1/2. Again, either is fine. From this, if I asked for the horizontal asymptote, so asymptotes are lines, you have to give me the full equation of the line. What's the equation of a horizontal line? Y equals a number. Okay. Can you look at this graph and tell me the horizontal line my graph is getting close to without crossing? Y equals 1 is the horizontal line. What's my vertical? If we look, our vertical asymptote, that's where my domain broke, because it involves my x's. My horizontal asymptote is where my range broke apart, because that involved my y's. Oblique, is there a slanted line here my graph is getting close to? No, there is none. Alright, so do you guys kind of understand what I mean when I'm talking about these different lines and intercepts here? So now let's talk about how to find them. You should probably be able to tell me how to find the x-intercept right now. Or sorry, that vertical asymptote. My vertical asymptote was at 2. Where did that come from? What was that related to, we said? That was our domain, right? The number that x can't equal in the domain is giving me a vertical asymptote. So if we have some big rational function, vertical asymptotes are x equals a number for any number that makes the bottom of the fraction 0. Horizontal are going to be y equals a number. There are different rules for this. So your textbook just kind of gives you a flat 3 rules. Here's, memorize it. This is why when you have a horizontal asymptote. And we'll kind of talk about those. I really want you to kind of understand where they come from. There are different options for how to get it. We can look at dividing by the highest power of x, or we can even think of it as like a division problem. So when we go through these, I'm going to kind of talk about some different options and see if we can pick out our asymptotes. So we're going to come back to this horizontal idea in just a second. First, let's practice vertical. So if I want my vertical asymptotes, where do I need to look? At what makes the denominator 0. So when I look at this first one, x squared minus 4, what makes that 0? So our vertical asymptotes, they are lines, so I want the equation. We have 2 of them. X equals -2, x equals +2. B? Right. So we get 1, so the vertical asymptote is x equals 1. Okay, this one. What would we did this one when we were finding domain. What makes the bottom 0? I. Can we graph I? No. So, in terms of this, my domain is everything. So what does that mean for the vertical asymptotes? There is none. All right, D, what would I have to do? So x plus 7, x minus 3. So my vertical asymptotes are x equals -7, positive 3. And E. We set the denominator equal to 0. To get rid of a fourth power, you do a fourth root. Anytime you add an even root, what do you have to put with it? So we get plus and minus the fourth root of 1, which is 1. So vertical asymptotes are x equals -1 and positive 1. So we've seen it's possible to not have vertical asymptotes. It is possible to have multiple vertical asymptotes. There's no set number. Any questions about finding the vertical? So let's talk about how to find horizontal. There are probably like 3 different ways I could teach you to do this. One of them is just memorizing rules. And that might be the easiest to get you through a test, but it's probably not going to stick with you after the test. Okay? Another option. We can think of this as a division problem. Okay, we've done long division, right? So if we set this up, like we are going to divide, this means the top divided by the bottom. Okay, your asymptote is kind of like the thing it's not going to equal. So if you think about dividing it, you would have a quotient and a remainder. Your asymptote is that quotient part, if we ignore the remainder. Now, if I go to set this one up, can I do x divided by 4x squared? No. So my quotient, can I divide it at all? No. This is all remainder here. So that means my horizontal asymptote is the line y equals 0. And this actually happens because the degree on top, the highest power on the top is what? 1. What's the highest power on the bottom? 2. Okay? If the top power is smaller, you're not going to be able to divide them, so it's going to be 0 every time. So anytime the power on top is smaller, it doesn't matter how much smaller. If it is smaller, it's an automatic y equals 0. Okay, our reasoning is this division. We can't divide it. If we look at, I'm going to come back to that in a second. Okay, if I look at this one. If I set this up like a division problem, you're missing some powers of x. You could put those in if you wanted, or at least the x cubed, because we're missing that. We aren't going to need to divide everything here. Okay, we're just trying to get a quotient, ignoring the remainder. And if it's a line, it's like y equals mx plus b, right? Can you do 3x to the 4th divided by x cubed? Yes. When I divide that, that gives me a 3x. Okay, so you can have your 0x's, whatever. You don't have to. Now we take 3x times all this. You guys remember doing this on our last test and quiz? So 3x times x cubed, 3x to the 4th. 3x times x squared, negative 3x cubed. 3x times 1 is a 3x. What do I have to do with all these sums? Change them. Okay. Positive 3x to the fourth and negative 3x to the fourth cancel. 0x cubed plus 3x cubed is 3x cubed. These aren't like terms, so I'm just going to bring it down. Negative x squared minus 3x. Now, we really only have to go one more step. Because I told you, I don't care about the remainder. I just care about the quotient, right? Y equals mx plus b. I have mx, I just need my last number. What is 3x cubed divided by x cubed? That's 3. Okay, that's all I need. The rest of it's just going to give me the remainder. I don't need to finish it. When I look at this, is this a horizontal line? No. A horizontal line is just y equals a number. This is an oblique asymptote. Y equals mx plus b. You will never get both horizontal and oblique. It's one or the other. The oblique happens because what was the degree on top? 4. What's the degree on the bottom? The top is 1 higher. So when you divide them, you get an x to the first. So anytime the top degree is 1 higher, you're going to get an oblique asymptote. All right. So we do the division, but we don't have to finish it. We don't care about the remainder. Which then wouldn't be an asymptote that we look at. Okay, so if I look at this one. If I were to set this up. All right. If you were to do your division, you do 8x squared divided by 4x squared. What do you get? 2. Okay, there is no need for me to go any further because everything else is just going to give me my remainder. This is my constant. If it's just y equals a number, that is a horizontal. Y equals 2. What was the degree of the top? 2. The bottom? 2. So we've kind of seen all of our rules here. If you're looking in the book, it just tells you these are the rules. Anytime the degree on top is smaller, it's automatically y equals 0, which we found. If it's the same degree on top and bottom, all you really have to do is divide these leading coefficients. 8 divided by 4 is 2. When the top is 1 bigger, you're going to get an oblique asymptote. You have to do that long division. All right, so you can remember the pattern or you can work it out just like we did. I didn't tell you the rules beforehand. I kind of showed you why they worked. So both ways will get us. If I look at this one, what's the degree of the top? What's the degree of the bottom? If it's the same degree, it's a horizontal. And we just have to think about dividing. If I set up this division, 3x divided by 1x is 3. So it's a horizontal, y equals 3. If you don't like that, you could work it out. 3x divided by x is 3. Okay, so if you can see it, great. If not, do your division. We're going to do just a couple more. This is going to be all we do today is working on these asymptotes. So if I look at this one, what's the degree of my top? 3. What's the bottom? If the top is 1 higher, when I take an x cubed divided by an x squared, what am I going to get? Going to get something with an x, right? So this is going to be what kind? Oblique. Okay, the only way we're actually going to get the oblique is to do the long division. But the good news is we don't have to do the whole thing, just part of it. I'm going to go ahead and throw in my zeros for my missing ones. You don't have to. If you don't, you just need to line up your terms carefully. What is x cubed divided by x squared? Okay, we take it times x. So x times x squared is x cubed. X times 5x minus 5x squared. X times 6 is 6x. Then what do? Change our signs. X cubed and negative x cubed cancel. 0x squared and 5x squared is 5x squared minus 6x minus 8. Okay, what is 5x squared divided by x squared? 5. And that's all I need. My oblique is y equals x plus 5. Is that okay? Let's look at this one. What's the degree at the top? What's the degree at the bottom? Does anyone know what this will be? Can you do x cubed divided by x to the 5th? No. So it's an automatic horizontal y equals 0. Anytime the degree on the top is smaller, it's an automatic 0. Let's do 2 more. All right. What's the degree of the top and the bottom? When I divide this, x to the 8th divided by x to the 5th, I'm going to get x to the 3rd. Is that a line? No. My asymptotes are just lines. If it's x to the 3rd, that's not a line, so that means there is no horizontal or oblique asymptote on this one. Okay, because if I actually divided it, I get x cubed. Asymptotes are just lines. Does that make sense to everyone? So we can have horizontal, we can have oblique, we can have none. Last one. Everybody take a look at it. Don't say it out loud yet. What do you think it is? What's the degree of the top? The bottom? Okay, can you do x squared divided by x to the 5th? No, it won't work out, so that's a horizontal y equals 0. All right. That is where I am going to stop today. Monday, we will start actually drawing graphs and looking at these. So I wanted to give you just a few problems from the book, not those problems, about these. 9 through 16, 37 through 45 odd, and 52 through 54.